Hey guys, welcome to the notes for writing linear transformations. So the second part of the video is going to be in a separate video just because the two pages are kind of different, just so that because one is like identifying and the other one is kind of more, we're processing things. So we are in Unit 4 and our essential question is how can we use function notation to describe linear transformations? And so remember from function notation in Unit 2, function notation just basically means that instead of using y, we're going to go and move it to f of x. So instead of using y like we normally would, we're going to use f of x. But remember, they're the same exact thing. Okay, now on this front page, we're talking about Fred. And so he's actually at a taco shop. And then we're going to have 3 different people that come into his life that have different situations based on Fred's situation. So they're basically comparing to Fred in all situations. So we have part A, part B, and part C. All separate from each other. They all have to do with different people. Okay, and this is very similar to how your homework is kind of set up. So in number 1, we have Fred buys X tacos for $3 each. The function f of x equals 3x represents the total cost. All right, so the function f of x equals 3x represents the total cost. So let's see if that really makes any sense to us. So I'm going to go ahead first. Now remember, what is f of x the same thing as? The same thing as f of x is y. So technically, if we wanted to make it more simple, it's kind of weird. But anyways, if we wanted to make it more simple, it would just be y equals 3x. Does this equation make sense? Like, does it make sense for Fred's situation? Well, yeah, because x is the number of tacos, right? It says Fred buys X tacos. So we know, right off the bat, we know what X represents. X is the number of tacos. Okay? X is the number of tacos. So we know that X represents tacos. Now, we know that they're also $3 each. So does this equation make sense to us? It kind of does, right? Because this is the number of tacos Fred could buy. X is the number of tacos. He could buy 3 tacos, he could buy 2 tacos, he could buy 7 tacos. Whatever that may be, regardless, they're going to charge it $3 per taco. For example, if he buys 5 tacos, how much would his total cost be? It'd be $15 because you do 3 times 5 and you get 15. So if X represents the number of tacos, what do you think f of x represents? What do you think the y represents? Well, it says that the function represents the total cost. The function represents the total cost. So remember, the function is f of x here, which means it's telling us that f of x is going to represent the total cost. Okay, so whatever x is, that's going to be the number of tacos, and however many tacos that is, we multiply by 3, and then we're going to get our total costs. So f of x is our total cost. Right, so if we wanted to break it down, we could do y equals 3x. Remember, this is the number of tacos, right? So if I buy 2 tacos, how much is that going to cost? It's going to cost me $6 because they're $3 each. So if I do 3 times 2, I'm going to end up getting 6. 3 times 2 is 6. So 6 is going to be our total cost here, right? So y represents our total cost, but we're not using y, we're using f of x. So that's just the important thing. F of x is our total cost. X is the number of tacos. So that's going to be something key for this problem, or for this problem together. It's a big problem. All right, so first problem we have is Gary. Gary has a 20% off coupon for Fred to use. Now in each situation, someone is going to come in and have either a free taco, free coupon, whatever it may be. So something's going to happen. And so we're writing transformations this time. The day before we did graphing transformations. So we were given a transformation and they wanted us to graph it. So we showed it that a line can move or be transformed based on that transformation. So when we're writing these equations today, the first thing we're going to have is we're going to have the transformation equation. So we're going to first write the transformation equation, and then I'm going to box that as one of my answers. So that's the transformation part. And then the second part of it is going to be the regular equation, or the simplified equation. So you can call it the regular / simplified equation. Okay, so, it's a regular or simplified equation. So we're going to have 2 equations for each of these parts. So first part, Gary has a 20% off coupon for Fred to use. So first off, right off the bat, let's just kind of talk about what functions are and what all of that is, right? So let's say I have f of x equals 2x. Let's say so this is my equation, f of x equals 2x, so like y equals 2x. Now let's say I make a transformation g of x equals f of x. Now we saw this yesterday in the notes when we were graphing. Now notice, are these different from each other? They're not. And the reason why they're not different from each other is because g of x equals f of x. They're equal to each other right now. So if I were to graph g and I were to graph f, they're going to be the exact same thing because I've set g of x equal to f of x. But let's say I wanted to move f of x down 5. Well, down 5 would mean I would subtract 5 on the outside, so it would be down 5. It would take our y-intercept there and then move it down. So it took the point there from the origin and moved it down 5. Okay, so if we're doing nothing to it, then they're going to be exactly the same. So that's just kind of a little bit of a reminder. All right, now, in each of these problems, we have different people. And so because we have Gary in the first problem, I'm going to call him g of x. So Fred is f of x, and that's pretty easy because Fred starts with the f, so we're going to use him as f of x. But with Gary, because he is a different person and we're going to apply a transformation, we're going to use g of x for Gary. So I'm going to use Gary being g of x. So Gary is going to be g of x for me. Okay? All right. Now, what do we know about Gary? Gary has a 20% off coupon for Fred to use. So let's just go ahead right off the bat and just set them equal. I keep saying right off the bat. I'm so sorry. I don't know why I keep saying that today. But g of x equals f of x. So I haven't done anything. Right now, they're equal to each other. So right now, I'm saying Gary and Fred, they're just paying the same amount as each other. Nothing new, right? And remember, this represents Fred's total cost. Remember, f of x represents the total cost for Fred. So right now we're just saying that the total cost for Fred is the same cost that Gary's going to have. All right. Now, Gary has a 20% off coupon for Fred to use. So let's think about that for a second. If you have a 20% off coupon, right? So if I have 20% off, what does that mean? Well, how much would I end up paying? Or how much would Fred end up paying? If he has a 20% off coupon, Fred would pay how much percent? What percentage? He would pay 80%, right? Because that's how percentages work. They're out of 100. So if you have 20% off, you're only paying 80%. Now, we need to go back to middle school and kind of review what percentages are, how we calculate percentages, and all of that stuff. So if we have 20% off, you're only paying 80%. So let's first make 80% a decimal, because when we're in algebra, we don't really use percentages when we're calculating stuff. We like to use decimals. So we have to convert the 80% into a decimal. Well, to write 80% as a decimal, okay, that what's going to be, remember, you're going to move the decimal place over to the right, or to the left too. So it's going to be 0.80 or 0.8, whatever you want to use. I'm going to use 0.80 though, because I just like to keep the 0 there. So remember, you're going to move that decimal place over 2 spots, and you're going to put a decimal right there. So our decimal, or our percentage here is now a decimal. It is 0.80. Now let's talk about percentages and how we calculate those things. Let's say I have a jacket or a shirt or whatever. You have a $100 shirt, right? If you have a shirt that's $100 and you have a 30% off coupon, if you have a $100 shirt and you have a 30% off, right? If you have 30% off, how much are you actually paying? You would pay 70%. Right? So how do I calculate how much I would pay? Well, I would multiply by 70%, but you got to make it a decimal, so it'd be 0.70. So you'd end up paying $70. Well, let's do a different example. Right now, PS5 is about to come out, right? So this is 2020, so PS5 is about to come out later this year. So let's say a PS5 costs $500. Let's say when you go and buy that PS5, right? You want to go buy it, you have a 15% off coupon. If you have 15% off, how much would you actually have to pay for it? You would have to pay 85% of the PS5, right? If you have 15% off, then you only have to pay 85%. So let's find out how much we would have to pay. Well, you would multiply by 85% because that's how much you would pay, but you need it as a decimal, so it'd be 0.85. So you'd actually only be paying $425 for that PS5 instead of the $500 because you're 15% off. Now, you don't want to multiply by 15% because that's saying you're only paying 15% of the PS4, which means it's only $75, right? So when you're saying that you have 15% off, you're telling yourself that you have to pay 85% of it. So you would multiply by 0.85 and you get $425. All right, so now that we've gone through the lesson of multiplying and all of that stuff, so I know that I'm going to have to multiply this 0.80 to the whole total purchase here. The question is, when I'm multiplying with transformations, there's two places we can multiply. And if we look back at yesterday, you can have numbers in two different spots. You can multiply a number in front of f of x, or you can multiply it on the inside next to the x. And I'll go ahead and replace these numbers with like actual numbers. So like 4 right here. Okay. Now, you can either have the 4 on the outside or 4 on the inside. Now, what does this do? Well, the 4, if it's on the outside, it's going to multiply to everything. If the 4 is on the inside, it's only going to multiply to your slope, okay? But in this case, what are we using? Well, we're saying that we have 20% off coupon, so you'd end up paying 80%, which is 0.80, okay? You'd end up paying 80%. Well, that means that I'm either going to have to multiply 0.80 to the outside or 0.80 to the inside, because we're multiplying. Because remember, I showed you that when we do this, we're multiplying to our price, right? The question is, where would that 0.80 go to multiply? Would I multiply it to everything or just the inside? And the answer would be that you're going to multiply it to everything. And here's why. He has a 20% off coupon for Fred to use. 20% off his whole purchase. So if we're doing his whole purchase, his whole cost, remember, f of x represents the total cost, right? This is your total cost. F of x is the total cost. So I would have 80% times the total amount. If you have 80% on the inside only, that means that he's only getting 80% off of tacos only. So like he wouldn't get 20% off of everything. He'd get only 20% off of tacos only, right? So here we would get 20% off of everything. We'd only have to pay 80% of it. Here we get 20% off of just tacos. And here's why. What does x represent in our problem? Well, x represents the number of tacos. Well, this would mean that you would only have to pay 80% for tacos only. So like no drinks, no chips and salsa, none of that kind of stuff, right? But this is for his total cost, so you want to multiply it to everything. So we would have 0.80 on the outside. So he has 20% off coupon, which means you would only pay 80%, so you're going to multiply whatever his cost is by 80%. Again, it is on the outside because you're multiplying it to his whole cost, the total cost. Remember, the total cost is f of x. You're going to put it on the outside. If you put it on the inside, you're saying that he's only getting 20% off on tacos, but he's getting 20% off on everything, so that's why it goes on the outside. All right, so that's our transformation equation. So the only thing that Gary had for us was a 20% off coupon, so this is the only thing that's happening in part A. All right, so this is our first part, the transformation equation. The next equation we need is the regular or simplified equation. So in order to get that equation, you first need to, we're going to simplify that. We're going to simplify this, right? Because this is great for transformations, but I want it in a way that I can understand it as a student, right? So what do we know? Well, I can replace f of x with something, and here's what I know. F of x, yes, f of x is the same thing as y, but what does f of x equal in this problem? F of x equals 3x, right? If f of x equals 3x, I'm going to substitute the f of x with the 3x. So I have g of x equals 0.80 3x. Remember, f of x equals 3x, so I'm just substituting it out. I'm taking out f of x, plugging in 3x. So remember, these are equal to each other. That's why I'm allowed to do that. Now, what operation is happening in between 0.80 and 3 here? Remember, that's multiplication, right? Remember, we're multiplying, because in order to get that percentage off, we want to multiply 0.85. So here we would multiply 0.80 times 3. Now, what is 0.80 times 3 in a calculator, right? Well, if I do 0.80 times 3 in a calculator, I'm going to get 2.4. But because we're talking about money, I'm going to do 2.40x. So I'm going to multiply 0.80 times 4, or 0.80 times 3, and I get 240. I'm going to go ahead and highlight this. And I'm probably going to change the color of this to match that. So this would be blue. All right. Now, can I simplify this equation any further? Nope. So I'm done actually here. Oops. This is as far as I can go. Now, this looks like a normal equation. G of x equals 2.40x. Now, what does that mean, right? So I have my transformation, and then I have my simplified regular equation. What does this mean, though? Well, what did the 3 mean at the very beginning? The 3 meant is how much I had to pay per taco. That's the cost per taco. That's what the 3 represents. So then what do you think the 2.40 represents here? That's going to be the cost for each taco now. So you're paying $2.40 per taco. Now, why is it less? Why did it drop from $3 to $2.40? Because you had a 20% off coupon, right? If you have a 20% off coupon, instead of paying $3 for each taco, you're only paying $2.40 for each taco because it's cheaper, and so you're having less money that you have to pay for it. Okay, let's move on to part B. Henry plans to buy 2 more tacos than Fred, and he plans to use a $10 off coupon. Now, Gary is out of the picture, right? Like, we're done with Gary. Gary's out of our lives. He's not important anymore for us, right? So now for Henry, this is a brand new person. So he's technically like a brand new transformation. We're going to transform our equation again, but this is a brand new one. So I'm going to use Henry and call him h of x. So with Gary, I used a g because his name started with a g. For Henry, I'm going to use an h. So again, as always, I'm going to set them equal to each other at the very beginning because we don't know anything yet. So we're going to assume that Henry and Fred are equal right now. Now, here's the thing. If you don't name it something else, if you name it g of x again, it's going to be very confusing. So, because what if you have to graph something and then you have 5 lines on your graph and they're all named g of x, so that's very confusing, right? So you always want to name different parts, different names, right? Like if I have 5 Alexes in a class, it's going to be really hard for me to say, hey, Alex, and then for them to know which one I'm talking about. So you tell them apart by either using their last name, but in math, we just use a different letter. So number 1, we talked about Gary, so I use g of x. In part B, I'm going to use h for Henry. All right, so let's go ahead and read this. Henry plans to buy 2 more tacos than Fred, and he plans to use a $10 off coupon. Now, we have 2 things going on here. The first thing that we have going on is that Henry plans to buy 2 more tacos. Okay, he's wanting to buy 2 more tacos. Okay. Now, we also know that, I need to use a different color. We also know that he's going to use a $10 off coupon. So we have 2 things that are happening right now. He's going to buy 2 more tacos, and he has a $10 off coupon. Well, we got to figure this out really quick because we got to finish the problem, right? Okay, so let's take care of the buying 2 more tacos part first. So he wants to buy 2 more tacos. So I know that's going to be plus 2. The question is, would I put it on the inside or the outside, right? So we have 2 different scenarios. We could have x plus 2 like this, or f of x plus 2. Now, he wants to buy 2 more tacos. Now, what represents tacos in our problem? X represents tacos, right? If I go back to the top, remember, x is the number of tacos. So if he's buying 2 more tacos, would I put it inside with the x or on the outside? It'd be on the inside with the x because x is tacos and you're buying 2 more tacos, so that's why the 2 would go inside with the x. You don't want it on the outside in that case because remember, if you add it on the outside, you're saying you're doing $2 more because remember, f of x is f of x is the total cost, right? So if you add 2 to the total cost, you're saying that you're paying $2 more for your total cost. That's not what we mean. We want 2 more tacos. So if we want 2 more tacos, tacos is x, you're going to plus 2 to the x on the inside of the parentheses. So I'm going to add 2 to the inside. Okay, so we have that. Now the next thing I see is that he also plans to use a $10 off coupon. Now we want $10 off his whole purchase, so we're going to subtract 10. The question is, would I subtract 10 on the inside of the parentheses, or would I subtract it on the outside of the parentheses? Well, this is a $10 off coupon, his whole purchase, right? So if it's on everything, you're going to subtract it on the outside, right? If it's on the inside, we're talking about tacos because X is tacos. So subtracting it on the inside wouldn't really make sense. It means he's getting 10 tacos for free. So we don't want to subtract it on the inside. We want it on the outside because it's to everything. Now, we took care of all of the things that Henry did, right? Henry buying 2 more tacos, and he's buying a $10 off coupon. Remember, we're comparing him to Fred. That's why there's still an F here. Okay, so that would be the transformation equation. So those are the 2 transformations that have happened. And now we're going to go ahead and do the simplified regular equation, quote unquote. All right, now we need to simplify this. So in order to do that, we've got to plug in what we know. So what do we know f of x is equal to? Remember in this problem, we substituted the f of x with the 3x because they're equal to each other. And here's kind of a little bit of a trick. See how there's an f here? And you see how there's an x here? See how there's a 3 here and there's an x here? What changed? So the x stayed the same. The f got replaced with a 3. So that's kind of what I do. So the trick is that if you see the f, you're going to replace it with the 3. So f of x equals 3x. So I'm going to substitute that in. So I have h of x equals 3x plus 2 minus 10. Okay. So what's the only difference between these 2 lines? What's the only difference? I replace the f with a 3. Now remember, f of x is equal to 3x. So the shortcut in my mind, and when I try to explain this, is that you just basically replace the f with the 3. So if the taco cost was, let's say, $6 each, so let's say there's a 6x and the tacos cost $6 each, then if I had an f, I would replace it with the 6. But I don't have a 6, so that's just kind of an example. So whatever f is, I would just replace it with that cost of whatever it may be. So in this case, I would replace it with 3. All right, now I have to simplify this down. So the first thing I would do is I'm going to distribute 3 times x. So I have h of x equals 3 times x is going to give me 3x. 3 times 2 is going to give me positive 6. And then I just have the minus 10 on the back. Now, the 3 doesn't get distributed to that because it wasn't inside the parentheses. Now, my next step here is I'm going to combine like terms. So have I used green yet? Oh, I have. All right. I haven't used this pink yet. So I'm going to combine like terms. So 6, and then that is painful. I am not using that color. Oh my gosh, that was hurt. Let's use this. So I have 6, and I have negative 10. Now, I can combine those, right? They're like terms with each other. So I'd have h of x equals 3x, and then 6 minus 10 is going to give me negative 4. Can I do anything else to simplify this equation? No. So then this would be my final equation, and this would be my simplified regular equation here. So what does this mean, right? Well, what does the x represent? Remember, x represents the number of tacos, right? X is the number of tacos. So how much do tacos cost here? Tacos still cost $3. So tacos cost $3. Right, they still cost $3, just like at the very beginning, they still cost $3, right? Because Henry doesn't have any taco percentage coupons, right? So tacos are still the same price. His tacos are still the same price. Now, in Part A, we had a 20% off coupon for those tacos, so that's why the taco price dropped. Whereas in Part B, taco costs are still $3. Now, what does the minus 4 at the end mean? Well, even though Henry ended up buying 2 more tacos, he has a $10 off coupon, so he's actually going to pay still $4 less than Fred. He's going to pay $4 less than Fred in the end. So what does 3 mean again? The 3 means that tacos are going to cost $3 each still, because he's still going to the same taco shop. They're still paying $3 for each of them. But that minus 4 at the end means he's going to end up still paying $4 less than Fred. And here's why. Henry's buying 2 more tacos. Now, how much do tacos cost? They cost $6, right? But he has a $10 off coupon, so that means he actually has $4 off, because those $6 minus the 10, you're going to have negative 4. So in the end, he still pays $4 less than Fred, even though he bought 2 more tacos than him. All right, last part is Kevin. He's going to go to a more expensive taco shop that charges 15% more, but he has a coupon for a free taco. All right, so what do we know here? Well, we know we have a new person. This person is Kevin. Now, again, every time you go to a different transformation, you always want to use a different letter so that you can tell them apart. So I'm going to use k of x for Kevin. And I'm going to set him an equal to f of x for right now. Okay, so there's 2 things that we know. The first thing that we know is that he's going to a more expensive taco shop that charges 15% more. It is more expensive, so it's 15% more. Now, Fred goes to a taco shop, right? In his taco shop, he would pay normally on a regular basis 100% of the price, correct? But Henry is going to a more expensive place. So you need to add 15% to this, which would equal how much percentage for Henry to pay. It's actually 115%. Now, I know that seems kind of weird because you're like, that doesn't make sense. You can't have percentages over 100. But in this case, because he's charging 15% more, you're actually paying 15% more, and the only way to represent that with percentages looks kind of weird. So Henry's going to a taco shop where he's paying 115% of the price. So he's paying 100% of it plus 15% more of it. Now, we want to write this as a decimal. And so to write 1.15 as a decimal, or 115 as a decimal, would be 1.15. I kind of gave the answer away. So you move the decimal place over 2, and you plop a decimal there. All right, so that's our decimal. Okay, now he's going to a more expensive taco shop. So I know I'm going to have to multiply the 1.15. The question is, would I multiply it on the outside or on the inside? Well, the whole taco shop is 15% more. So everything is 15% more. So I would put it on the outside. So be 1.15 on the outside because it is the whole shop. If it was on the inside, you're just saying that only the tacos are 15% more. Remember, X is tacos. So if you do it to just X, you're saying just tacos are 15% more. But this whole taco shop is 15% more, so that's why it's on the outside. The next thing that's happening in this taco shop is that you have a coupon for a free taco. Now, tacos is what variable? It's X. So I know that I'm going to have a free taco, and X is tacos. So I know it's going to be on the inside with X because we're talking about tacos. So tacos is X, correct? Right? X is the number of tacos. All right. So if X is the number of tacos and he's getting a free one, I'm actually going to subtract 1. And the reason why I would subtract is because it's free. If I were to add one, you're saying he's buying one extra taco. He's getting charged for one more taco, but he's getting it for free, so that's why it's minus. All right, so we took care of both of the transformations. So this is going to be our transformation equation. Whoops, my line is a little crooked. This is our transformation equation here. Then the next thing we're going to do is we're going to simplify this and make it a regular simplified equation. So we would have k of x equals 1.15. Now remember, the trick is just replace that f with the cost of the tacos. How much does a taco cost? Cost $3, right? So remember, f of x equals 3x. So I'm just going to replace the f with the 3. So I'm going to go down here, replace the f with a 3, and we have x minus 1. Now what operation is happening between the 1.15 and the 3? It's multiplication, so you want to be super careful about that. Now you want to multiply that part first. So you want to do 1.15 times 3 first. So let me highlight that, 1.15 times 3. So we have k of x equals 1.15 times 3 is going to give us 3.45, and then parentheses x minus 1. And then we want to simplify by distributing. So we're going to do 3.45 times x, which is going to be 3.45x. And then 3.45 times negative 1 is going to give us negative 3.45. All right, so is there anything else that we can do to this equation? Nope, we've simplified it as far as we can. We don't have any like terms anymore. So this is our final equation that is simplified. Now, what does this mean? Well, let's think about this. X is the number of tacos. How much do tacos cost here? Tacos cost $3.45 each. Now, why is it more now? Right? Why do tacos cost more now? Well, remember, his taco shop is 15% more. So it makes sense because the other taco shop was $3, and if this is 15% more, each taco is going to be $3.45 each. Now, where do you think this minus 345 came from? Well, remember, he got a free taco. So he got a free taco as well. And that's why that negative 3.45 there is there. All right, so that is the first page, going over writing transformations using functional notation, writing the transformation equation, and then the simplified regular equation. If you have any